again. Good morning, good afternoon, or good evening, wherever you happen to be. And thank you for joining us for today's webinar titled Understanding and Accessing ZOS Catalogs. Like the card catalogs in the libraries of old, the ZOS catalog identifies the location of and provides copious information about every recorded data set in the system. Catalogs and their components, the BCS and VVDS, are critical ZOS resources. Almost any request for information about files, volumes, or data in a mainframe system requires that the catalog be accessed. There are several different ways of accessing catalog information, and in this webinar, our presenter will discuss catalog structures and topics such as the LOCATE and CAMLST catalog access macros and the catalog search interface that allow you to easily retrieve almost any sort of information from the catalog. We'll also provide a couple examples that you can use to generate your own catalog-based reports. This presentation is sponsored by DTS Software, a US-based software developer located in Raleigh, North Carolina. DTS is a recognized global leader in enterprise storage management technology for IBM ZOS, Hitachi VOS 3, and Fujitsu MSP operating systems. The company was founded in 1991 and currently has more than 1,000 customers in North America, Europe, and Asia. For more information on DTS, please visit dtssoftware.com. Our speaker today is DTS Software Chief Technology Officer Steve Pryor. Steve has more than 30 years experience in storage management, design, and support, and speaks frequently at industry events. Prior to joining DTS in the early 2000s, Steve made important contributions at several mainframe software vendors, designing and implementing major products and components. At the end of Steve's presentation, we will have a short Q&A session. Attendee microphones are muted for the presentation, but you may ask a question or request webinar assistance at any time during the webinar through the webinar chat dialog or ask a question interface. After the webinar, all registrants will receive a copy of the slide deck as well as a link to watch the webinar on demand or to forward to colleagues. At this time, I will make Steve the presenter. And take it away, Steve. I guess I have to unmute Steve first.
Yeah, thanks, Ray. Good morning, everyone, or good afternoon, as Ray said, or wherever you happen to be. In the little video we just showed you there, we talked a little bit about many of the original developers still being part of DTS software here, and of course I'm one of them, and I've been working with ZOS for a long time, longer than I care to let on. And one of the things, of course, that you get involved with in ZOS is storage management, and if you get involved in storage management at all, you have to do, in fact, if you're working at a vendor all in an ISV at all, you wind up doing a lot of work with the ZOS catalog. And so what I'd like to talk about today is the catalog, what it is, the basics of the structure of the catalog and what it contains, and how to get at it and how to get that information. There's because ZOS has been around for so long, there's a lot of different ways to get different types of information out of the catalog, get different pieces of information out of the catalog, and generally the information you want to get is of one of two types. You want to get a list of data sets out of the catalog, or you want to get information about some particular data set, and possibly both. And so we'll talk about how we go about doing that. What we're typically looking for when we access a catalog is where is the data set, what volume is it on, and then what does it look like, what are its characteristics. So a catalog, sort of by definition, is a place where we keep information about data sets. So it's a metadata repository. The primary key, of course, is the data set name. There are a couple of different types of catalogs, of course. In fact, there are really three in the ZOS environment. There's a master catalog and a user catalog, which are really the same thing, and then possibly a special catalog for tape, SMS managed tape information called the VOLCAT catalog. So we've got this metadata information, and we've got a picture here of a good old-fashioned library card catalog. Now, of course, an antique, but I certainly spent many hours when I was in college looking through catalogs like this, and it would be very difficult, of course, to find a particular book if you simply walked into the library and they didn't have some sort of method for looking up the shelf and location of the aisle on the shelf that that particular book is on. Otherwise, it would be chaos. You'd have to look through every book, and so a card catalog is really a very close analog to a dataset catalog. So it contains the dataset name and information about where the dataset lives, primarily the volume serial number, but other things as well, the information about, just as in a book, how many pages are there, what's the subject of the book. There's lots of other information that's in the catalog for any particular dataset, as well as pointers to other catalogs. So when we allocate a dataset, if we have a DD statement here, DD1, DD dataset name equals my dataset, and disposition share, and I submit a batch job for that, before the system can actually make that dataset available to me, it has to find out where it is. And given a dataset name, typically we want to know what volume, what disk volume the dataset resides on. And so for every single DD statement that we might code in our JCL or that we might reference in our TSO session, there's a catalog lookup that's going to occur, unless you explicitly hard code the volume serial number in the DD statement. And so there's lots and lots of catalog lookups, and they have to go very fast, and they're very frequent. And so there is a single SVC, a single supervisor call instruction that is devoted to catalog access, SVC 26. And it is used for two purposes. It's used for obtaining information from the catalog to find out typically what volume a dataset resides on, or given a dataset name mask, what datasets meet that criteria. So we can obtain information from the catalog. And the other side of SVC 26, which we won't really talk about too much today, is updating the catalog. SVC 26 is used to define clusters, to delete datasets, to alter information in the catalog, to add volumes or delete volumes in catalog entries. So there are really two sides to SVC 26. One is to retrieve information from the catalog, and the other is to actually create or update information from the catalog. So when we're talking about where is the data set and what does it look like, we have to talk about what the catalog is. And conceptually, it's fairly simple, although the details of the catalog records can be quite complex, because again, like everything else in ZOS, the catalog structure has been around for many, many years. And so the catalog itself is actually a two-piece thing. It's a two-piece piece of metadata where you have the BCS, and that's usually what we refer to when we're talking about a catalog is the basic catalog structure, the BCS. And that is, the BCS is simply, structurally, it's a VSAM key sequence data set, variable length span records, and it's organized by key, and the key is the data set name, because typically we go to the catalog, for a given data set name, we want to obtain that information, and so the records are keyed by data set name, plus one additional byte, which is the type of data set or the type of record. And so there's a 1 byte record, 1 byte field at the very end of the key. So the keys of the BCS are 45 bytes long. That tells us whether this is a VSAM cluster entry or a component entry, index or data component, or a GDG entry, or various others. There's about a dozen different types of possible BCS entries. And so there is a BCS entry, therefore, for every cataloged data set in the system. And in most environments today, all of the data is SMS managed, and so there is, one of the reasons that for that is that if we have, it is possible certainly to have uncatalogued data sets in the system, but you have to keep track of them yourself. They can't be managed, and so they're something that resides if the library books that are outside of the card catalog, and no one knows about them. So the for SMS managed data sets, though, the golden rule of SMS is that the data sets must be cataloged. And so there's an entry in the BCS, and there is the second part of the catalog is the VVDS, or the VSAM volume data set, which is structurally, again, it's a somewhat like the BCS. It's a VSAM entry sequence data set with a name of sys1.vvds.v volume serial number. And so each BCS is associated with one or more VVDSs, and the VVDS tells us about the data sets that reside on that particular volume. So the BCS tells us where the data set resides in its records, and the VVDS tells us more detail about that data set in the as it resides on that volume. And of course, we also have the volume table of contents, which is not part of the catalog, but it is a system data set. The VTOC resides on every volume along with the VVDS, and it contains some of the detailed information about the data set, the extents, where it resides on the volume, and so on. So we'll talk just briefly about the BCS, the basic catalog structure. And this is normally, when we talk about a catalog, we're really talking about both the BCS and the VVDS, but typically when you say, I want to deal with a catalog, you're talking about the BCS itself. And it contains information, records. The records contain information, well, there's a record for each data set, and there's in fact many different types of records, but there's a record for each data set. For each data set, it will tell us about the location of the data set, that is volume serial or volume serials, possibly the relative track and record number of the DSCB and the VTOC, so that we don't actually have to scan the VTOC. Some other cells within the record, the owner information, if there's a data set owner, security, association records that tell us what other catalog BCS records are associated with this data set. Most importantly, the SMS class names are in there. There's really two types of records in the BCS. What's called a sphere record, which basically is all of the catalog information that particularly for VSAM data sets, that's related to a base cluster, and then there's non-sphere records. The thing that's not in the BCS is extent information or data set attributes or statistical information. That's kept on the volume, and that's in the VVDS and the VTOC. So the BCS can be either a user or a master catalog. There's no real logical difference between them. The difference is the master catalog contains pointers to the user catalog and other things such as alias names and important sys1 dataset names and so on. But typically the master catalog does not contain dataset level information, whereas the user catalog, which is physically identical, will contain information about individual datasets and the volumes and the owner and security and SMS class names for them. There's also a second type of catalog, which we mentioned, or a specialty type of BCS called the VOLCAT catalog, which you define when you're you can do an IDCAMS define user catalog and specify the VOLCAT operand, and that contains information about tape libraries and tape volumes that exist on the system for SMS managed tape. The VOLCAT catalog, however, does not contain any tape dataset information. That's the province of the tape management system. So the other part of the catalog, of course, is the VVDS, and it's the one that one is probably more likely to more likely to report on in detail, because it contains all of the details for a data set. Besides just the association records, it also contains the SMS class names, but it contains things like the cluster name for VSAM, the extents on which the data set resides. So there are really three types of records in the VVDS. And again, there's a VVDS on each volume, and that VVDS contains records that point back to the BCS. So there is a BCS name record for data sets that are cataloged and reside on that volume. The VVR describes the VSAM data sets. The NVR record describes the non-VSAM data sets. And so all of that, when we say it describes it, there's a lot of information in there. There's creation date and expiration date and extents and encryption keys and all kinds of or encryption key labels. And that's usually the information, along with perhaps some information from the BCS, that we want when we access the catalog. So this is a list of the catalog record types. The BCS has, we said the key for in the BCS was the dataset name, 44 bytes, plus 1 byte to indicate the type of record. So an A record is a non-VSAM dataset, a B record is a GDG, C is a cluster, D is a data component, and so on. So there's 10 or 15 different types there. The VVDS is actually a little bit simpler in terms of the number of record types. There's really just a couple of types of VVRs and an NVR and some control records. And each record, as we said, is divided into cells or subcells that contain all of the detailed information that we might want. The volume serial number is contained in the BCS, but the extents on which the data set resides, its attributes, is it extended format, is it non-extended format, is it EADR, is it large, is it does it have a is it encrypted, is it compressed? All that information is in the VVDS, and all of this stuff is documented in the Managing Catalogs manual. There's just a few manuals that are related to the catalog that we'll talk about as we go through. So what we want to find out, of course, is what does the data set look like? That is, what volume does it reside on, and what information can I get back from it? Can I get the when it was created, when it was deleted, what its DCB, what its allocation characteristics are, what extent it resides on, and so on. Typically, the way one gets that is simply IDCAM's listcat, and IDCAM's listcat is obviously, pretty easy to use. We can simply do program IDCAMs, and we can say listcat level or listcat entry. One of the problems with IDCAMs, though, is if we want to obtain a list of data sets, well, the masking is pretty limited. I can use a % for a single character or an asterisk for a single qualifier, but I can't use an asterisk at the end. But it's pretty easy to use. And the information I get back, for example, I did a listcat level here for anything with beginning with SJP and ending with data, and one qualifier in the middle. And what I wind up with, if I don't specify anything else, is simply the dataset name, a list of dataset names, and the catalog in which they reside. If I want more information, of course, I can specify a couple of parameters here. There's not much. I either get all of the information back or just a little bit of it. I can specify history or vols here, but usually one specifies all. And so for a particular individual data set or a list of data sets, oops, that's sjp.vsam.plus. I get a lot of information back. I get information on, for example, for a VSAM cluster, there is all of this information comes from cells, that is components within records of the BCS or the VVDS. There's a history cell. There's some SMS data cell, which tells me there's an SMS data subcell that tells me what's the data class name, the storage class name, the management class name. It tells me about the RLS attributes if it's a record level sharing VSAM data set. And then in the, I might have other things. I might have, is it encrypted? Is it password protected? I might have related records as part of the sphere record. I might have alternate index components and path names. And the data component there, but the details for the data component, as we have here, the details for the data component and the index component, this information, average LRECL, buff space, EXCP exit, number of splits, all of that is coming from the VVDS. So the listcat is returning me information from BCS and from the VVDS, and it's really obviously the easiest way to get information back, but it's in a very rigid format. It rarely changes. Rarely there might be new cells added to catalog entries once in a while, but the format of IDCAMS is rigid, and that's actually a good thing because it allows us to post-process it. And so if I have, to take another real quick example, here I'm going to list all of the volumes in the VOLCAT catalog, that is our tape our tape configuration database. This is a catalog exclusively for tapes for a particular library, and I can send the output to a data set, which I can then parse with a rex exec if I want. So this is just a very simple rex exec here. I'm going to first step, I'll go and do a listcat for volume entries in the catalog, and I will write it out to a data set via the out file parameter. And then I can take that out file parameter and process it with a rex exec. So we can just run that real quick. And if we look at this particular data set, actually, I think I have to delete it first. And then submit it. If we look at that particular data set, it contains, again, some very rigidly formatted information about every tape volume in this particular catalog, in this VOLCAT catalog. So if I want to, I could have a rex exec that would pick out things like what is its status, or what's its owner, what's its storage group, what library is it in, and probably most importantly, its use attribute, is it private or scratch? And so that's actually the second step of this job. We go and print a list of, we simply strip out everything and this is all the volumes that are in non-scratch status, and this is all the volumes that are in scratch status. The rex exec for this looks something like this. It is and it's really very simple. We simply read the record in, and then we look for the particular field that we know is in the listcat. We can strip out that information and write it out, and we can count the number of private and scratch and total volumes and so on. So one way to get, the easy way to get information that doesn't require any assembler programming, that doesn't require any particular expertise, is simply to post-process IDCAM's listcat. Okay. Or ISPF 3.4 or ISMF. There's a couple of if you're a TSO programmer and you don't mind doing assembler, there's a couple of TSO service routines you can call. ICQ GLC00, which is not terribly well known, but you can give it a data set name mask similar to listcat. and it will return you a list of data sets meeting that naming convention in an ISPF table. And there's similarly, there's another TSO service routine, IKJ-EHCIR, which will return you, again, a list of data set names matching some naming convention. The problem with listcat and with the TSO service routines is that the masking really isn't very good. There's really a single qualifier, asterisk, and a single character % sign. What you'd really like is a little bit more flexible masking to be able to say, I want to see any number of qualifiers, I want it at the beginning, at the end, and we have that available, but not in listcat. I don't know why IBM has never put it in listcat. That would solve a lot of problems. So all of these, so we can typically from the catalog, we either want to obtain a list of dataset names, which we might do with listcat or ISPF 3.4 or ISMF, or we want to obtain information about a particular data set, and we want to obtain some detailed information, which is typically done with SVC 26. And as we said, SVC 26 is the catalog locate SVC. It is used by the system to find out where a volume resides, what volume it's on, and to update the catalog if we're doing an IDCAMS define or alter and so on. So we've talked about, there's a couple of, again, the TSO, we can obtain that information, catalog information from TSO, but all we really get is the vol-seer for a data set or maybe a list of data set names. Oops, the typical way that vendors have in the past obtained catalog information is via locate and CAMLST name macros. These are assembler macros that will return the volume serial number for a given dataset name. And from there, you can go and get further information. But very often what you want, or what the system wants, or what you want, is to know where does the dataset live. So for a single dataset name or for a high-level qualifier, locate and CAMLST macros, the CAMLST is the catalog management parameter list. You have to use both macros together in assembler, will return information about the first 20 volumes, disk volumes, on which a dataset resides. For VSAM, you've got to give it the cluster name, but for a non-VSAM dataset, of course, you just give it the dataset name, and it looks something like this. There's a locate instruction that points to the CAMLST. The CAMLST is simply another macro. It just really defines a data area. And so down here I have my CAMLST, and there's a couple of different forms of CAMLST. The typical one is name. That is, the parameter list contains a dataset name. So CAMLST name, I give it the actual name of the dataset, which is here called my.data.set.name, and the place I want to return the information. So the myCam tag here refers to a CAMLST macro, which is the catalog parameter list. And the locate macro really just points register 1 at the CAMLST and issues SVC 26. And then, of course, the result of the SVC 26 or of the locate macro is returned in register 15. It will be either successful or unsuccessful. So we can specify using locate and CAMLST name, we can specify some particular dataset name and get back information about the dataset. But really, the only information we can get back is the volume serial numbers that the dataset resides on. And so it will give us, it returns that information into a work area, a volume list, and the format of the returned work area is a 2-byte length of the used information used, and then a 12-byte entry for each volume, which contains a 4-byte device type field, followed by 6 bytes of the vol-seer, followed by the volume sequence number, because the dataset might reside on multiple volumes. And so this is typically the way that many application programs, many vendor programs, especially ones that were written some time ago, obtain information about where the data set lives. And this is usually the first thing you need to know is, given a data set name, what volume does it reside on? Because when we have that DD statement that references the data set, disposition, older disposition, share, the only way that the system knows what volume it resides on is to do a catalog locate. So locate and the CAMLST name macros, which are in the scarily named DFSMS DFP Advanced Services Guide. There's lots of information, lots of interesting stuff that you can do in there, some of which requires APF authorization. Locate does not. So anybody can write an assembler macro or an assembler program to use locate and CAMLST name. But all of the detail on that is in the DFP Advanced Services Guide. There's also further information. You can also use the CAMLST macro along with the catalog rather than locate macro to actually alter a catalog entry. Of course, that does require some authorization. So locate CAMLST name is one way of obtaining information out of the catalog, but only the vol ser information. We might want other information, and so there's a couple of other ways to get information out of the catalog before we get to the big component, which is the catalog search interface. There's 3 or 4 DFSMS DFP callable services, and so I can issue, and these are programs that are in the linked list that I can call, and this is documented in the same manual in the Advanced Services Guide. I think it's documented in the Advanced Services Guide. Yeah, to retrieve. Typically, one thing I might want to know is, what are the SMS classes associated with this data set? Particularly if I'm doing a report, I want to know what data sets have a particular data class or management class or storage class. Well, for any given data set, I can call IGW ASMS, the attribute retrieval service, to get the data class and the storage class and the management class names for a particular data set, as well as a flag that tells me whether it's a PDSE or not. There's another callable service, another program that I can call from my program, but again, these have to be done in assembler. I can get the backup while open attributes. This is typically used for data sets accessed by CICS. Also, typically for CICS data sets, I can get record level sharing, RLS information, things like the log stream ID, the log type, is it none or undo or redo, is it RLS quiesced, and so on, and timestamp. So I can issue a callable services macro if I want certain types of information, typically the class names for a data set, but I've got to give it the particular data set name, and it will only work for one data set at a time. If I actually have the data set open, if I'm reading or writing the data set, I can call the is it managed macro. This requires, the input to it is a DCB that's open to the data set, and it will give me back a bunch of flags for some other information. It will tell me whether or not the data set's SMS managed. Unfortunately, it doesn't tell me the class names. For that, I will have to call IGW ASMS. But it will tell me, is it SMS managed, yes or no? Is it a PDSE? Is it extended format? Is it compressed? Is it encrypted? Is it a Unix data set, and a couple of other things? But that requires that the data set be open and that you be reading it via BSAM or QSAM or BPAM. So we have a couple of ways of getting either a data set name or a list of data set names, and some information out of the catalog, the attribute retrieval service, typically for the data class, management class, storage class names. And probably the easiest way, though, that doesn't require some assembler, besides just post-processing listcat output, is rex list, the list DSI function of rex. And this is just it's a TSO external function, so it will only work in a TSO environment. And it's simply a list, a rex function that I can call, and says, and return me information about the data set from the catalog. It actually returns information from the catalog, and optionally from the VTOC and the VTOC as well. So I might have a list DSI job here. I'm calling, in this case, I have a rex exec called DS info, and we can take a quick look at that. And so my list DSI is simply, I specify a variable name equal list DSI, the data set name, and the type of information I want back. I want the volume serial numbers, I want rack if information, I may want the data set recalled. Most importantly, I want the SMS information. So whatever parameters I specify on the list DSI rex function will be returned in a series of rex variables that all begin with sys. So sys DS name, sys volume, sys unit. And so if I want to run a quick list DSI on two of my data sets here, I can run a list DSI on sjp.smstest.1 and sjp.vsam.plus1. And this particular little exec just goes out and does a list DSI and prints out all of the returned information. And so what we can see is for a particular data set, the rex variable sysds name, sys volume is filled in, sys unit, LRECL block size, and so on, primary, secondary space, and some information that's strictly in the catalog. The data class, the management class, the storage class. Is it encrypted? This particular one is, and tells me what the key label is. So list DSI in a rex exec is a really easy way to get some information out of for a data set out of the catalog. Unfortunately, it doesn't work very well for VSAM data sets. You get a warning return code, and it will tell you the volume serial number and not much else. The other information is just question marks. All right, so list DSI, but for most non-VSAM data sets, rex list DSI, so long as you can do it from either TSO or a batch TMP program, list DSI will get you lots of information into 48 different rex variables, much of which comes from the catalog. Finally, IBM many years ago decided to release into the wild something that vendors had been using for a long time, and that's the parameter list, SVC26. SVC26 has actually two different forms of the parameter list. One is used by the CAMLST and LOCATE macros that we saw before, which will return you just the volume serial number information. But there is a much more complex version of the parameter list that vendors had been using. It's never really been properly documented. And so IBM finally decided to give the users something they could actually use to get back not only lists of dataset names or lists of catalog entries, but any particular field in the catalog they might want back for those dataset names. And so it's really a simplified version of what is referred to as the generic filter locate function of SVC26, which allows you to specify a full wildcard entry name. So instead of having to specify just a single qualifier asterisk or a single character % sign, I can use all kinds of different, I can use full wildcard name masking the same way I do in DFDSS and in HSM and in the ACS routines. I can return it returns information from multiple data sets on a single call, because it's really just an SVC26 call. Although the program name is IGG-CSI00, what it really does is pass your parameter list to SVC26. And it will return information for any catalog field that you like. And of course, you have to know the catalog field name that you want. Do I want the vol ser? Do I want the creation date? Do I want the encryption key? Do I want the primary or secondary space? Do I want the record count? And so there can be a lot of information returned. And so it's returned into the work area. And if the work area is full, you can resume it. The nice thing about IgG CSI 00 is the parameter list is very simple. It's fairly easy to process, and it's normally called from assembler, but you can write a rex exec or call it from something from a high-level language. Even there are some examples on the internet for calling it from COBOL. So the parameter list looks like this, and it's really very simple. Register 1 is pointed at a 3-word list, and those 3 words point to 3 different areas that are going to be used by IgG CSI 00 to determine what data sets I'm interested in, what catalog fields I'm interested in, and where that information is to be returned. So the first field, so register 1 points to the first word, is a pointer to the return code area, basically, the return reason code. The second word pointed to by register 1 is your selection criteria. What data sets do I want? What fields do I want? And the third is the pointer to the work area, which is where the information is returned. So it's really quite a simple parameter list, although there's a lot of sort of smaller parts to it. And so we'll sort of skip over the return reason code because that's obvious. But the selection criteria is a series of fields so you have a pointer. Register 1 points to a pointer to the selection list, which is actually mapped by IgG CSI NA. And the important parts of that are the 44 character name that you want. That is the name of the data set or the data set name filter. So I might return multiple data sets with a single value in CSI filter K. I can limit it to particular characters if I want to specify a catalog name, and up to 16 bytes of different entry types. The entry types, if we remember, are A for non-VSAM data sets, C for clusters, D for data components, I for index, G for GDG. So you can tell it not only what name you're interested in, what entry names you're interested in, but what types of records I want out of the catalog. I want these entry names, but only if they're GDGs. Or I want these entry names, but things that match this dataset name filter, but I'm only interested in the index components. And then a list of, for anything that matches that filter, the entry name, the dataset name filter, and the type of entry in the catalog. Then I have a bunch of 8-byte field names or dictionary names that tell me what information I want. Do I want the encryption key? Do I want the secondary space? Do I want the creation date or expiration date, and so on? And so the field names are really the key to this. That tells me the entry name or filter name tells me what's called the filter key or filter key. The entry name tells me what data sets I'm interested in. The entry type, type D field tells me the types of entries I'm interested in, and the field names tell me what actual data I want returned. So the filter key can be a generic mask like prod.abc %d.**.xyz***. So I can have a fairly, this may pick up any number of data sets. Optionally, as I said, I can specify a catalog name, and then the entry types, which might be, they might be user catalog names, they might be data component, index component names, they might be volcat entry types, and then our list of field names. The field names are in a table in DFS managing catalogs, and there's quite a few of them. There's probably 100 or more of them. It's not every name that the catalog search interface will support. They only document some of them. There are a number of undocumented ones. But each field name is 8 bytes. You can specify 100 of them. And there are things like device type, storage class. I want the storage class name. I want the creation date in a 2-byte format or a 4-byte format. The particular field name that you specify is going to depend, the information that gets returned depends on the field name you specify. So if I specify, and it can come in any number of different forms. Some field names are for bit strings, some field names are for character information, some field names are for date, some field names are just binary information. So for example, if I specify a field name of high allocated RBA, that's 4 bytes information returned. If I specify a field name of XHA, X high allocated RBA, then I get the high allocated RBA back as 8 bytes. If I want the encryption information, that's a 96 byte field. So I've got to have a large enough work area. And there's some of these fields repeat. I might have multiple vol series. I might want to know the number of extents. All of this information can be obtained from the VCS and the VVDS for every data set that I specify in the filter key. And then the result is return, if assuming it's successful, return code, as you expect, the return code's on register 15, and 0 is success, 4 is I get some stuff back, anything higher than that, there was an error. And so the reason code area is the same. It's the same thing you get back if you did an ID-CAMLST cat and you got an error. You might see an IDC 3009I message. That's the error that's returned. Return code and reason code in the area pointed to by the reason area. Okay, so the work area is where the information comes back, and it comes back. The work area you set up. You tell it in the first word how long the work area is, and you make the call to catalog search interface. And upon return, he tells you how much of it he used. Or if you didn't give him enough, he tells you how much you need. So the third byte tells us how much third field tells us how much we need. And then the following the length of the used work area, it's a 2-byte field that's the number of field names. So however many field names you specified, plus 1, because it starts with 1. It's the number of field names that are returned, and all of the catalog all of the information you asked for is returned in the work area, and it's returned in a format that tells you what catalog I got the information from, what the entry name is that relates to that you asked for, and that matched your naming convention, and then information for each field you asked for. So if I asked for 3 different fields, say data class, management class, storage class, for each returned dataset name, each entry name, I will get 3 field name fields. And the field name, so the format of the field names, the format of the information returned in the work area, as we said, is information about the catalog it was returned from, information about the dataset name, the entry name, and then the field name. So the returned information is the catalog information is a 45-byte field, the catalog name preceded by F0, which is the catalog type. And any errors. And then there's 1 entry for each entry name that's returned. The entry name is the dataset name, and the type is the record type, data component, index component, and so on. But what we're really interested in is the field name information. And so there's one entry for each field name we specified. So if I specified 3 field names, there's the information is returned as the length of field 1, the length of field 2, the length of field 3, followed by data for field 1, data for field 2, data for field 3, up to 100 fields if I want. Now sometimes those will be empty, because if, for example, I asked for if I asked for the encryption key, for example, it will either be entry or minimal if the data set's not encrypted. Or if I asked for an expiration date and there is no expiration date, it might be binary zeros. I have to know what the field name format data is going to be in order to process it. But this all requires assembler code. Well, not necessarily. Fortunately, IBM has given us some samples in Sys1 Sample Lab that are pretty straightforward, easy to use. So in Sys1 Sample Lab, there's assembler code for IgG CSI LC, which basically lists all of the types of entries, the data component, index component, GDG, and so on, in specified catalogs, or to show the VSAM statistics for a catalog. The one that's probably of real interest is IgG CSI VX, find all the data sets for a given catalog on a particular vol-seer. Again, these are all assembler examples. There is a Rex example called IgG CSI RX that will return you the given a filter name, given a dataset name, or a dataset name mask rather. It will return you the entry name, the type, and the vol-seer, and it's very easy to modify just to add some additional field names. And still easier, if you go to the IBM FTP website, and you can do this. You can log in as anonymous FTP here, but it does have to be TLS secured. But you can log in here as anonymous FTP and get something called the Cat Search I Rex exec, and it will simply format the catalog search interface and call it from Rex. So with whatever field names you specify. So if I have a dataset name called sjp.smstest.whatever, I can use my full masking here. I can say I'd like these field names back, the vol-seer, the data class, storage class, management class, maybe the key label, maybe the creation date. Again, I can look up the field names in the manual. And if I go here, I can look at, let's see, cat FRCHI. And if we actually look at that Rex exec, oops, this is the Rex exec, and it's got some documentation, tells you about the valid types you can specify, work area, but basically this is provided by IBM, and it will initialize all the variables, and it will go and actually call IgG CSI 00 eventually. It will call IgG CSI 00 via address link PGM, IgG CSI 00, and that will be kind enough to format the returned information for you for all of the field names that it knows about. And so if I want to take this and just run this and get information for a particular set of data sets, and I want the vol-seer, the data class, the storage class, and so on, it will return to me. It'll tell me what catalog it was found in, what type of record it was, in this case a non-VSAM record, a type A record, and the field names I asked for, the data class, the management class, the storage class, the key label, and the creation date in hexadecimal. It will do it for every data set that I asked for that met my naming convention filter. So sjp.sms test.1.2 and anything else that matches my filter. So Cat Search I is really useful way to call catalog search interface from Rex. For our products, we do interface all of the DTS products, which are typically used for standards enforcement or for space error recovery. We interface obviously with SVC26 and with catalog and allocation and volume processing. We actually get control and front end allocation and volume processing, and we front end SVC26 as well as a couple of other SVCs so that we can enforce standards about where data sets are going to be allocated, regardless of what you coded in the JCL, we might override it or override the value in the ID-CAMS control statements to allocate or extend the data set in the way that we want. So where is all this documented? These are the manuals that you may want to look at. So let me, at this point, I think I have just a couple of minutes left. Let me open it up for questions, and then we'll talk about next month.
Well, we did have kind of a, I guess I'll say generic question. Do you have sample JCL or programs for the TSO service routines?
I don't. The manual itself will tell you how to use them. I'm not sure that there aren't really any examples in the manual itself. I think there may be some sort of minimal examples in the TSO programming services manual. Generally, those are to return lists of data sets, and they are sort of this, they'll return to you sort of the same information you would get out of an ID-CAMS list cat. But if you would like lists of data sets and you don't have too much need for sophisticated masking, they're pretty good. And one of the nice things is they will return it directly into an ISPF table. But unfortunately, I do not have an example of that, although I'm sure that Dr. Google probably has one somewhere.
All right. That was really the only question we had outstanding at the moment.
Okay, well, let me just go on a little bit and talk about next month. Next month, we're planning the next webinar on June 27th. I want to talk a little bit about exit routines. Whether or not you know it, you do have some exit routines in your environment. IBM has sort of had been on a vendetta over the past number of years to say, oh, exit routines are bad, you shouldn't have them, we're going to replace them. And of course, they never really replace them, and they simply live out there forever. They can actually provide you with a lot of useful function. There are exit routines for almost every function, for HSM, for DFDSS, for allocation, for SMF, for end of volume. And so we'll talk about what the exit routines are, where they'd be useful, particularly things like HSM exits, and how you might go about coding them without knocking yourself out. Just a couple of reminders, our current product release is now available. And I have finally managed to sort of automate our method of analyzing your ACS routines. And so we can hopefully get a little faster turnaround on those. So if you want to send us a copy of your ACS routines so that we can maybe take a look at them and give you some recommendations on them, feel free to send those to us to support@dtssoftware.com. And we'll be that's the sort of thing we like to do, is look at ACS routines, believe it or not. And so, we're certainly interested in what problems you might have in your environment that we might be able to solve, because we're all about problem solving. And so at that point, I'll turn it back over to you, Ray, for any other questions or anything else we might have.
No additional questions at the moment. Just a quick reminder to everybody out there, there are a few handouts in the presentation if you want to go ahead and download those. Additional handouts and product information are available on our website at dtssoftware.com. And within the next 24 to 48 hours, we will send out an email to all registrants with a copy of the slide deck and a link to the recording. And I believe that about does it for us. Again, if you have any other questions, feel free to send those to us at support@dtssoftware.com or steve@dtssoftware.com. Thanks everybody for attending, and I'll leave the session open for a few more minutes so people can download the handouts.